Hello everyone, it's time to do some more programming. We're currently solving Advent of Code in Elixir Livebook. To give a quick recap of where we are, or to give a quick recap of the story arc this year, we're trying to fix the snow machine and make Christmas happen, but we haven't actually gotten to the snow machine. On the first day, we started off in a submarine and got launched out of a trebuchet to an island of elves. We then played a game of colored cubes with an elf, and then helped another one fix a gondola machine to go up a mountain. Yesterday, instead of actually going up a mountain, we traveled to a sky island of sorts, and there we helped an elf compute his scratch card winnings. The input looked like this, where each line was its own card. Each card had the set of winning numbers and the list of numbers that were actually on the card. Our task was essentially to find which numbers in the second list were members of the first. We did this by just turning the first list of numbers into a set and then checking which numbers in the second list were members of said set. Part 1 just required us to raise 2 to the number of winners, and Part 2 required us to follow a slightly more complicated algorithm to compute. It was an algorithm that required us to duplicate cards and then compute how many more cards we'd get later in the set. It's not particularly interesting, it just required us to iterate through the list of cards once. Day 4 was a bit unusual in that it seemed a lot easier than the previous days. These Advent of Code problems frequently involve some amount of parsing, and the parsing on the third day was actually tricky. Fourth day, however, was absolutely trivial. It just required a couple of string splits and nothing really else. We're solving Advent of Code in Elixir Livebook, and Livebook is kind of like the Elixir implementation of Jupyter notebooks. Except it's better in many ways, although also less featureful. It gives us a nice web browser interface where we can write Elixir and then see results directly underneath. It makes live coding these Advent of Code challenges much nicer and much more interactive. So without further ado, let's look at day 5. Day 5. If you give a seed a fertilizer. You take the boat and find the gardener right where you were told he would be. So we got the boat from the previous day's elf who we helped with the scratch cards. Managing a giant garden that looks more to you like a farm. A water source. Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we've ran out of sand to filter it with. Can't make snow with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days, weeks. Oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Almanac just arrived, and we're having trouble making sense of it. The almanac, your puzzle input, lists all the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, and what type of water to use with each kind of fertilizer, and so on. So, seed, soil, fertilizer, water. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are reused by each category. That is, soil 1, 2, 3 and fertilizer 1, 2, 3 aren't necessarily related to each other. For example, here's the slightly more complicated parsing. Seeds, seed to soil map, soil to fertilizer map, fertilizer to water, water to light, light to temperature, temperature to humidity, humidity to location. For a map, it's a bit unusual that there are 3 numbers. I think I would have intuitively expected only 2 numbers on each line. The almanac starts by listing which seeds need to be planted. Seeds 79, 14, 55, and 13. Okay? The rest of the almanac contains a list of maps which describe how to convert numbers from a source category into numbers in a destination category. That is, the section starts with seed to soil map, describes how to convert the seed number, the source, to a soil number, the destination. This lets the gardener and his team know which soil to use with which seeds, which water to use with which fertilizer, and so on. Rather than list every source number and its corresponding destination number one by one, the maps describe entire ranges of numbers that can be converted. Each line within a map contains 3 numbers: the destination range start, the source range start, and the range length. Consider again the example seed to soil map: 50, 98, 2, 52, 50, 48, which is indeed the seed to soil map. The first line has a destination range start of 50, and the source range start of 98, and the range length of 2. Oh, so this presumably applies to numbers, to seeds 50, 51, and 52? No, probably just 50 and 51. Oh, the first number is the destination range, and the second number is the source range. So, this line means that the source range starts at 98 and contains 2 values, 98 and 99. The destination range is the same length, but it starts at 50, so it contains 2 values. So its 2 values are 50 and 51. With this information, you know that seed number 98 corresponds to soil number 50, and that seed number 99 corresponds to soil number 51. Oh, so it's still a one-to-one mapping, but so this is just a shorthand for writing one-to-one mappings. It's not that anything in a range maps to anything in the other range. Do we actually have a line, a seed 98 or 99? We don't. But then on the second mapping, we'll have a range of length 48. So this will cover 55 and 79. The second line means that the source range starts at 50 and contains 48 values, 50, 51, and so on to 97. This corresponds to a destination range starting at 52 and also containing 48 values, 52, 53, and so on. So seed number 53 corresponds to soil number 55. I noticed that we could probably just sort the difference between the 2 mappings and then the length of the range instead of storing the individual mappings. Right, so we know that 50 maps to 52, so the delta in this mapping is always going to be 2. Right? 53 maps to 55. So for this line, we'll really just have to store a delta of 2 starting at 50 and length 48. So the entire list of any source numbers that aren't mapped correspond to the same destination number. So seed number 10 corresponds to soil number 10. Does this actually help us in our mapping here? So 14 maps to 14 and 13 maps to 13. Okay, So the entire list of seed numbers and their corresponding soil numbers looks like this: 0, 1 to 1, and so on, 48 to 48, 49 to 49, and then 50. 50 gets mapped to 52, 51 to 53, 96 to 98, 97 to 99. What was 98 here? So 98 gets mapped to 50, and 99 gets mapped to 51. All right. With this map, we can look up the soil number required for each initial seed number. Seed number 79 corresponds to soil number 81. Seed number 14 corresponds to soil number 14. 55 to 57 and 13 to 13. The gardener and his team want to get started as soon as possible, so they'd like to know the closest location that needs a seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. Location. Location is the last map, so we're going to have to pass these values through multiple transformations and then come up with the lowest number. To do this, you'll need to convert each seed number through other categories until you find its corresponding location number. In this example, the corresponding types are seed 79, soil 81, fertilizer 81, water 81, and so on. So the lowest location number in this example is 35, which will be the last one. What is the lowest location number that corresponds to any of the initial seed numbers? Right, this is doable. So we are going to have to parse the list of seeds, then parse a bunch of maps, then run the seeds through each map, or map-like thing. Now, question 1. Do we actually need the seed to... do we need to parse this sort of seed to soil, soil to fertilizer structure? Like, is the list of maps always in order, or is it sometimes out of order? So we start seed, seed, and then we have soil, soil, fertilizer, fertilizer, water, water, light, light, temperature, temperature, humidity, humidity, and finally location. And what does our real puzzle input look like? So we start with seed, then we have seed to soil, soil, fertilizer, water, light, temperature, humidity, and finally location. So it doesn't look like we need to actually parse these headers. We just need to parse the maps. It also looks like the maps have very large numbers in them. So there is no way we are constructing an actual concrete map of 1 to 1, 1 to 2 to 2, 3 to 5, and so on. That's just not feasible. But on the other hand, we also don't have a lot of seeds. So we don't need to optimize this in any meaningful way. We can just process it manually. Right. Okay, let's get started. We'll do the parsing first, and then we'll do the transformations. We're doing this in Livebook, so we start up, we create a new notebook. This is going to be called AoC 2023 Day 5. We save it to avoid catastrophic data loss. Not here. In repo, AoC 2023. This is Day 5. We're going to need Kino as a dependency because we want to use the Kino inputs in order to read our input. All right. First section is called helpers, like always. Then we're going to have two inputs, one for the example and one for the full test input. So example is Kino input text area example. And then we have a second one, which will be the full input. Let's call it full. Let's now copy our inputs here so that we can process them later. Yep, and the full input. Next up, we're going to have a new block. This is a new section. This is going to be part 1. We'll probably need to move the parsing into the common area later, but well, we can do that once we actually need to refactor. For now, we're just going to do tune input read example, and this should give us the text of the example. Yes. Let me just quickly clear my clipboard to avoid an unfortunate Wayland Firefox Livebook bug. Okay, we have our input. I noted that the sections are separated by double new line, so we can start by splitting on that. Right, and this gives us the seeds, and then the seed to soil map, which still has single new lines inside, then the fertilizer to water map, then the next map, then the next map, then the last map, then the next map, and then the final map. Oh, and for once we don't have a trailing empty string at the end. Next, we're going to handle the first element here and all of the other ones differently. So then seeds line maps lines. We're pattern matching on the list to separate the first element and all the other ones. And we're going to return a map of seeds. Let's just put seeds line in here for now, and maps, which will be maps lines for now. And then we will parse this into something more usable. Right. Let's now actually do the parsing. So seeds line is not going to be seeds line, it's going to be parse seeds. We don't have a parse seeds function, but we're going to define it. We're going to have to put it inside of a module because Livebook and Elixir more generally doesn't like top-level functions. We don't need to add a guard here to make sure that the input is a string, but I prefer to do it like this because it avoids bugs later on, or rather it catches bugs later on. So our seeds line is the word seeds followed by colon and then space and then a space separated list. Oh, so we can do this, we can match even harder here. We're going to match on seeds, space, and then str as a binary. Now we don't need the guard anymore. And now we just have the list, and we just pipe this into string split. And this gives us the actual numbers. So now the question is, do we need to convert this into numbers, or can we leave this as a string? Conceptually, we can keep this as just strings because we're just matching. So the seeds don't need to be numbers exactly, but we'll need to convert them to numbers once we go through the maps because we'll need to do arithmetic on the entries in the maps. So we convert this to a list of integers. And here I'm using the Elixir syntax for just referencing a single function. Okay, and we have 79 through 13, which is 79 through 13. This is good. Next up, we need to parse the maps. We'll again we'll put this into a function for readability, AoC parse maps. Parse maps. And this we know contains multiple lines. Actually, let's just call it str. Is it? No, yeah, let's call it str for now. We check that it's indeed a binary. And now here, we'll have to start by splitting on new lines. No function clause matching AoC parse maps. And this is why we always add a guard, because we called parse maps with a list of maps rather than with a single string. And I'd rather just call it with a single string. So I want maps lines enum.map, and we're going to be calling parse maps on each of these values. And now let's split this up onto multiple lines to improve readability. Right. And now parse map is not defined. It is indeed not defined. And now it works. Maps is one entry for each of the map. And then we have C2 sol map, and then the lines split in each map. We've already decided that we don't care about the actual name of the map, because the maps are always given in order. So, tail. Okay, now we just have the numbers. Now we just have the number lines for each map. The numbers are the source category. Where does it say? The maps describe the entire ranges. So the map contains three numbers: the destination start, the destination range start, the source range start, and the length. So it's destination, source, and length. So for each of these lines, we will have to parse destination, source, and length. So first off, we take the line and we string split it. Then we turn it into integers. It seems to work. Next, we are going to match on this list, and we know that each list has exactly three elements: the destination, the source, and the length. And then we're going to return it as a 3-tuple. We'll return it as a map. A map is probably less error prone. Destination, source, and length. The following arguments were given to the function. We gave it an empty string, presumably because the strings split here returned an empty list at some point, right here. So the last line gets parsed as an empty list. But we can fix this with a trim. Second argument. Am I misremembering that trim is a function? The trim is an argument to split. Elixir. I'm not misremembering. But if we give it an option, we also have to give it a pattern. We cannot just give it the option. So here we split on spaces and then we trim. And this still ended with an empty list at the end, because presumably we actually have to do the trimming here, not below. Yes. Okay, and we do not in fact need this trim. We do not. All right. And now, if we uncomment this, we should get our nice maps of maps. So for the first one, it's destination 50, length 2, source 98. Destination 50, source 98, length 2. All right, this works. This is our parsing. So next up, we need to do the actual work of passing the seeds through each of these maps. How do we do that? So say we start with seed 79. We have to figure out which, again, we could optimize this in many clever ways, but we don't really need to because the full input isn't actually that big. Like, there's not much point in optimizing traversal through these maps, given that the maps are maybe 30 elements long, and we have maybe 30 seeds in total. So we can just do this the simple way. So we take 79, and then we iterate through every element in the first map and find the one that matches it. Oh, so the one that matches it is the one that will have where 79 is between source plus length. Is between source and source plus length. So 79 will match the second map because it will be between 50 and 50 plus 48. So let's add another function. This function will take a number, take one of these maps, and return either a number or nil. It will return nil if the number doesn't actually match the map. Let's call this traverse. It should really probably be called map instead, but map is probably a function in Elixir, and it generally has an established meaning, and we're not using that here. So we have number, and then we have the map, which has a dest, an src, and the len. Now, this syntax I've always personally found a bit annoying. I really like the Rust optimization where if the key in the map and the variable have the same name, you only have to specify one of them. So for instance, in Rust, we could just write it like this. But this is sadly not a thing in Elixir, so we have to duplicate every word in the map. And we're going to say when is integer num. Do we have an end? Right. So first, if src is less or equal to none, and none is less or equal to src plus len, then we do the mapping, else we say nil. If we do the mapping, we are going to do num plus destination minus src. I think this is correct. So first question, are we off by 1 in num less than src plus len? So in our example here, we have 98 of length 2. So the two possible values are 98 and 99. This has to be strictly less than src plus len, because we have an inclusive range at the beginning and an exclusive range at the end. Next up, is the transformation correct? We map num plus destination minus src. So here, destination minus src is going to be 50 minus 98. 50 minus 98. I don't need the second code block, so it's minus 48. And then if we map what is one of our seeds, if we map 55 to this, we do this. Yeah. We get 7. All right, so this is clearly wrong. Yes, this is clearly wrong. So 55 should have mapped to... Oh, no, this is not clearly wrong. 55 doesn't even match this. Does it? I'm getting confused about what the source and the destination are here. So the source is 98. So it would not have matched this map. It would have matched this map, which is destination is 52 minus source, which is 50. So this maps 55 to 57. Is that correct? $55 to $57, right. They've already done this work for us, so let's just output something that looks a lot like this. And then we can test whether we're computing this correctly. So we have our traversal function. We have our seeds and our maps. So next we're going to do, like, we could combine, we could fuse this pipeline a bit, but I think it's more readable this way. Especially because then I'll be able to do an IO inspect here and actually see the seeds and the maps. Seeds, maps. So we're going to go over every seed. And then we're going to, it's a map because we're going to map over every element in that list. Then for each seed, we're going to fold, we're going to reduce over the maps. Reduce. We're going to be using the second version of reduce that also lets us specify an accumulator. And the accumulator starts off as seed. Then we're going to have a fn, we're going to have the map, and it's the number. We're not calling it seed here because it's only a seed on the first map. After the first map, it will be a soil, and then it will be a humidity, and so on. And here we're just going to do AoC traverse seed and map. And I realize that our traverse function isn't quite right. So according to the rules, if we don't, any source numbers that aren't mapped correspond to the same destination number. We're missing one level of iteration here. So here we're mapping over the maps, but the maps, each element in the maps list is actually going to be a list itself. So here, so for each, this is also actually a plural maps, and we have to figure out, this is a map list. And then we have to find one element in the map list where traverse is not nil. And if all of them are nil, then we just have to map it to itself. Any numbers that aren't mapped correspond to the same destination number. So here we're going to do list.find value. No. enum.find value. What's the documentation for this? Can we see it? Let's just check the library. enum find value. Similar to find, but returns the value of the function invocation instead of the element itself. The returned value is considered to be found when the result is truthy, neither nil or false. So this is exactly what we have. So enum.findValue, we're going to search in the map list. We're going to search in the enumerable. Then we don't specify a default, but we specify a function. And our function is just going to be AoC traverse. AoC traverse seed map. And so this entire find value is either going to return nil or the new value. So we're going to do case do. If it's nil, then we just return num. And here we don't traverse with seed, we traverse with num. And if it's not a num, if it's new num, then we return new num. And this really is the default, isn't it? Yes, we can specify a default, so the default is going to be num here, and then we don't have to do this case. Is this it? Well, this certainly printed something, but unfortunately it thinks it's a char list, so it makes it annoying to read. So we're just going to... Oh, but this also isn't quite what we were trying to do. We actually want to inspect the intermediate values so that we can check that this computation is happening correctly. So for each map traversal here, I want to IO inspect the result. I feel like this is not at all what I expected to get. Is it? So the problem is we're going... Well, first off, I don't actually know what this number is. We are just not including enough information here. So let's stop being clever and then just say new num. And here, IO inspect. Num becomes new num. Seed. Let's include the seed as well, so that's probably important. Right. And now here we have the same new num. Right. So, seed 79. 79 becomes 81. 79 becomes 81. 81 becomes 81. 81 becomes 81, and then 74. 81, 81, 81, 81, 74. Then 74, 78. So then the numbers are 78 and 82. 78 and 82. Right, this worked. So let's check the other ones. For seed 14. So we have 14, 53, 49. 14, 53, 49. Then we'll have 42 and 43. 42 and eventually 43. 55 is 55, 57, 53. 55, 57, 53, 46, 82. 46, 82, and eventually 86. And we do indeed end in 86. So finally we have 13, 13, 52, 41, 13, 52, 41, 34, 35, 34, 35. All right, so this actually worked fine. And our ending list is each seed passed through all of the maps. So we commented this out, we commented this out, and now here, I think we just have to output, here we just have to output a num.min. Is a num.min a thing? 35. The lowest number in this example is 35, all right? And now we try this with the full input. It's not called full input, it's called full. And this is a large number that will be hard to debug if something breaks. But it did not break. This was in fact the right answer. So we have 1 gold star. Okay, we now continue to part 2. But first, I triggered the Livebook bug, or the Wayland Firefox Livebook bug that involves the clipboard. So I have to clear my clipboard. This is not my clipboard. This is my clipboard, and clear it. And now I can reload this, and the bug is gone. Okay. Block section part 2. Okay, let's read the description for part 2. Everyone will starve if only plant such a small number. Everyone will starve if you plant such a small number of seeds. Regarding the almanac, it looks like the seeds line actually describes ranges of seed numbers. Okay, the values on the initial seeds lines come in pairs. Within each pair, the first value is the start of the range, and the second value is the length of the range. So in the first line of the example above, seeds 79, 14, 53, and 13, this line describes 2 ranges of seed numbers to be planted in the garden. The first range starts with seed number 79 and contains 14 values, 79 through 80, 79 through 92. The second range starts with seed number 55 and contains 13 values, 55 through 67. Now, rather than considering 4 seed numbers, you need to consider a total of 27 seed numbers. In the above example, the lowest location can be obtained from seed number 82, which corresponds to, say, soil 84, fertilizer 84, water, and so on. So the lowest location number is 46. Consider all of the initial seed numbers listed in the ranges on the first line of the almanac. What is the lowest location that corresponds to any of the initial seed numbers? Okay, so we have, it's the same basic problem, except our number of inputs has increased drastically. And I bet that if we look at the full input, the ranges are going to be huge. Yeah, these numbers look huge. We cannot iterate through every element in this range to find the smallest number. That's just not feasible. So now we have to do the same thing as with part 1, but this time we have to do it based on ranges rather than on individual numbers. The interesting complication is, of course, that ranges can be split by the transformation. So, for example, 79 through 14, this line describes 2 numbers, the seed number 79 and 14. Okay, so the ranges are specified as starting point of the range and then number and then length of the range. So this is 79 with 14 values, and this is 2 billion something with 1.6 billion values. So we can start this by mapping 79 through the map, and we find which map entry it matches. It will match this one. But then we can't iterate through it, so we will find the ending of the match, the ending of the range. In this case, it's of length 48, so mapping this range through this map goes entirely through this transformation here. That's easy. But the second one, 55, 55 of length 13. This also goes through this transformation, so it's easy. But presumably we could come up with a number here where it doesn't just go through, where it gets split. So for example, if our input here was 97 and length 2, then the first value, then 97, would go through here. But then 98 would go through here. This would give us two disjoint values. But there aren't that many stages in this transformation, right? We have 1, 2, 3, 4, 5, 6, 7. So we don't have to worry about a combinatorial explosion if every value just gets split into multiple stages, into multiple maps. Sorry, if every range... Let me back up a bit. The risk here is that we take a range, then we pass it through one of these maps, and then we get 2 ranges as a result, or potentially 10 ranges. And then we pass it through the new map, and each one of the 10 ranges now becomes 10 ranges of its own, so we now have 100 ranges, and so on. However, there are only 7 stages here, 7 maps that we have to go through, so it will never actually be a particularly large combinatorial explosion. So we can just do this. We don't have to remerge ranges or anything of the sort. Okay. So what can we steal from part 1? All of the AoC stuff is still valid. Parsing the maps is still correct. So let's start with this. We go back to the example because it's shorter. And we have our maps and our seeds. However, this time the seeds are slightly different. The seeds here need to be chunked. Enum.chunk every 2. So we have 2 pairs of seeds now. We have 2 ranges of seeds. Well, let's do this the boring way, and then we can perhaps do it we can optimize it if it's too slow. So we pipe this through IOInspect because we'll still need to, it will be useful to see what these values are. And then we do then fn feeds and maps. Then again, we have to go through every element in the seeds, and we will do seeds enum map. But this time we have the start and the length of the seed. Now we need a function that is very much like traverse, except it doesn't actually do the match. It returns the actual map. And we can just do that. We have that. It's enum find. So previously we used enum find value to also actually take the value out of traverse. But this time we only care whether it returns a value or not. And while we're on the subject here, let's just do list.first. List.take1. I only want to see the first transformation to make this easier to reason about. And Same for seeds, in fact. Let's just only look at the first pair of seeds. And here we're going to do find seed start in the map. We don't have a map. We didn't call it a map here, did we? We called it a map list. Num.find. So we take num dot this is a bit deep in the data structure and I'm having trouble reasoning about it. So what happens if I run this? List.take doesn't exist, of course. It's called a num.take. Right, and this just gives us the maps. So for every map, we want to see whether, yes, for every map, we want to find the map where AoC traverse returns something useful. Map line. Then we want to do AoC traverse seed. This is not seed start here, this is maps. AoC traverse seed map line. Why is there an error? There's no value called seed. Right, it's called seed start. We called it on a list of maps. Why did we call it on a list of maps? Right, because now for each seed we actually have to do something over every map. So we're going to do enum dot reduce on the maps. We start with seed start, and then we take a num, map lines. Is it called map lines here? Map list. Map list, and then we do something. And the thing we do is what we were trying to do earlier. And here we iterate over the map list. Then we take each map and see if we can traverse the seed through it. Right, and here I got the order of the arguments wrong. Here, instead of seed start, we're going to do num. So this is saying that the first seed goes through this, managed to go through this map, which is correct. So now that we know which map it went through, we have to figure out whether it caught the whole range or just a part of the range. If map dot, we know that this is right, so we need to get the ending of the map. So it's map dot src plus map dot len. If this is strictly greater than seed start plus seed len, then we've completely managed to pass this particular range through the map. So then we just return, well, we return AoC.traverse num through map. So this is the start of it. This is, yes, this is, well, it shouldn't be called num, should it? Right, here this is incorrect. we need to pass both seed start and seed len. And then here, instead of num, we're going to say range start, range len. And these are going to be tuples. Then here we're going to find not num but range start. This is even more readable. Here we're going to say if map.src plus map.len, this is, so the question is, have we fully done the traversal here? So, okay, so let's do this bit by bit. Enum.find, have we found any map? If we haven't found the map, then we know that the range hasn't changed. So we just return range start, range len. If we have found the map, then we need to first compute new range start, which is just going to be AoC traverse range start through the map that we found. Now, we have a map. So the question is, did we manage to get the entire range through the map or only part of it? So if map.src plus len is equal to map.src is not quite what I want. What I want is map.test plus len minus map minus new range start. So how much of the map's destination range is still available? If how much of this range is still available is greater than range len to do greater or equal. If the whole range was mapped through, then we can just return the whole thing. The whole thing is going to be new range start and range len. So this is the case where we haven't split the map in two. Else, something. Okay, this should now run because the first range was completely went through the first map completely. And it does. It says 81 with range 14. With length 14. And is this actually correct? From range... The line describes two ranges. Now rather than considering seed numbers, in the above example, the lowest number can be obtained from seed number 82. Is 82 the number we're considering? I don't know. No. Or it will be at some point. But for now we have to do this manually. So 8114. Is 81 correct? 7914 must have gone through this one. So this just adds 2. So it was indeed 8114. And 8114 is completely included in the destination range, which goes up to 98, but not including 98. I'm going to move the input here because we're going to be manipulating this. We're going to be messing with this a bit. Damned Livebook bug. This is where it becomes really annoying. So I want a new Elixir here, and we're going to call it test. No, input text area. Right. We have this, then we take the whole list. We trigger the bug, but we don't care, because we've managed to copy paste the thing we wanted. Now we can reload this, and it should hold the value. Yes, and now here, instead of doing example, we're going to go through test. And the input is unchanged. However, if I change this one to not be 48, but instead be of length, let's call it 33. This will now return something because we're in the second case. This will now return something because we're in the second case. Yes. So now, second case, we have split the range. Actually, first off, let's figure out if it's greater or equal here. So what happens if we want the result to be at exactly the edge? The edge is 79 plus 2, 81, plus 14, 95. 95, so this is 45 here. This should still be in the first case, not in the second case. Right? No, because 95, 81, 14 shouldn't actually go into 95. It should end at 94. So this is the very end. This is the very end of the range, right? But now we want to split it. So let's just do 33. So let's solve. Okay. So one of the ranges we have is definitely new range start and new range len. What is the new range len? New range len is this. Well, let's do new range end. Right. New range end is going to be this. This was basically our problem. New range end. And then here we're going to do new range start, and new range len is going to be new range end minus new range start. Well, this didn't work at all. This didn't work. Because this is actually the len. And this now looks really odd. No, this is not the new range, and this is the map range length. Right. This is the map range length. So this is as far as this particular map it gets us. So this is map range len. Okay, so if we do 79 of length 14, we pass it through this one, and this one takes us, the last number we can map from here is 83. 83 is a flank, 83 is indeed 4, I think. I think this is correct. I don't know how to convince myself further. Maybe we should write it down. Writing it down is probably a good idea. So we have to map 50 to 83 into 52 to 85. So when we map 79 of length 14 is 83, 93. When we map this will map to plus 2, 81 to 95. But we can't actually fit the 81 to 95 into this one. So this is actually split into, this will be 81 through 85, which is what we got here, 81 of length 4. One, 2, 3, 4. This should be 5 here. Okay, it will be split into 81 through 85, and then 86 to 93 to 95. Right, now, am I off by 1 everywhere? So 50 to 83. 50 of length 30. Right, so this is actually not 83, this is 82. Then this goes from 52 to 84. This is 79, and it ends at 92. 92. This goes from 81, and it also ends a bit earlier at 94. So this gets split into 81 to 84, which is what we have here. And then 85 to 94. Okay, so we've done the first half of this, we need to do the second half. But of course, the second half isn't actually a half, because we might have to do this multiple times. Interesting question is, are the ranges overlapping? I think the mapped ranges can be, yes. Yes, there's no reason to assume that they wouldn't be. Okay, so this has to be, so we're going to have to move this whole thing into a function, into a recursive function that will find the right map multiple times. Yeah, so that's interesting. So this will take, this is the function we need to extract. So we're going to put this into a new module because just to keep it closer to the code here, Okay, this is going to be called traverse range. Traverse range. And it will take a map list, a range start, and a range end. Do this should still compile. Yes, this still compiles. Okay. And here we're just going to replace it. AoC2 traverse range, and this is the function that takes 2 arguments. Yes. And we'll probably have to do some more manipulation here because traverse range is going to be returning a list of ranges. So we won't be able to continue the reduction without doing some other fanciness. Alright, so map range. We have a map list and then a range start and a range end. Okay, and then here we return the new map, but let's also return leftover, what are we going to call this? It's going to be new range start plus map range len, and it's going to be range len minus map range len. So what I'm hoping this will return is this. I want to find this value. So 85 of length 10, which is 85 to 94. Okay. And now that we have this new range len, we're going to just call traverse range on it with the same map list. So this is our recursive call. And let's split this onto a new line to make it easier to read. Well, this didn't actually improve things all that much. There's just too much text going on here. Oh, that just means we have to split it into even more lines. That doesn't look nice. This still doesn't look nice. Let's split it like this. All right. So this is our recursive step. We also need a base case. What's our base case? Our base case is when our range len is 0. Traverse len, we don't care about the map list in this case. We don't care about range start. We care about range length being 0. In fact, we should never actually reach this case because we'll have this should stop the iteration here. And this also returns the list now. This also returns the list here. And this might not actually be correct. Let's just recheck. Okay. So here, in fact, if we have, since we should never get to this point, we'll just need to say range len when range len is less or equal to 0, do raise something went wrong. Or rather, this can't happen. And if we ever get this error, we'll know that we have to debug this spot here. Okay, I ran it, and okay, so now the result is... Did I run it? I felt like I just ran it, but it didn't do what I thought it did. Oh, it did do what I thought it did because 85 through 10 don't actually have a mapping, so it went into this case here. So really I want to increase the length, I want to increase this 14 here to be something that exceeds 98. So 98, we're going to do 21, which should get us up to 99. Okay, and now we see the bug. This got us up, this now says 85 through to 17, but this really should have mapped through here. So this case was wrong. This is the case that actually got triggered, right? Pop-up. Feature. Bad case. Yes, this is where that number came from. So this is incorrect. So what's going on here? We're going out of a range. We end up having to split the range like this, but 85 doesn't actually go through any of the maps. So we just map it to itself. But then some number is going to some future number. This is not 85 anymore. Let's just update our computation here. So it's 79 through 99. Yeah, and this maps to 81 through... Well, this is supposed to map through something else. It maps into 81 through 84 as before. Right, let's just try the second case here. So this is 98 through 99, maps to 50 to 51. Right, so this maps to 81 to 84 and 85 to... So everything up to 7 to 98 should map correctly. Since it's 98, it should be 97. The last two numbers don't map. So 97. And then 98 and 99, the last two numbers get mapped to 51. This is the answer we're hoping for. And this is the answer we got instead. We got 85 through to the end because it didn't handle this case. This is all really convoluted and it's going to result in an error at some point. Maybe we just need to do a bit more processing on our maps. Like, if we have this, then it becomes a lot easier. If we do the search through this in a sort of sorted way, then it becomes a lot easier to do this sort of reasoning. So what does this mean? It means we have to sort by SRC first, and then sort by SRC len, and these ranges shouldn't overlap, and then we should just add the missing ranges to simplify our logic. Okay, so never mind this whole thing, let's try to simplify. Let's start from scratch. Well, not exactly scratch, but close enough. So we start by reading our input. And we have our maps and our seeds taken as pairs. And also, yeah, we're still basically only taking the first, we're only looking at the first stage of map transformations in the first set of seeds. So next we're going to do enrich seeds, basically. Yeah, we're going to start seeds, maps. Oh, not enrich seeds, but enrich maps. And then we're going to return seeds is unchanged. Yeah, we can just data maps new maps. Yes, and the new maps is, well, let's just say maps for now. Okay, unchanged. So, first thing we're going to do with the maps is sort them. Sort by, and this takes a map and sort. This takes a map and just returns map.src. So now the maps should be sorted by the source. Right? We start here with them sorted the wrong way around. We want this to start with 50 and then 98. All right, because we have multiple levels here. Num.map, and then map list, and then sort by, pipe map list into this. Okay, so now we have the first map and then the second map. And now we need to fill in the middle bits. So basically we want this. So we have these two maps, but we really want to generate this one. 83 to 97 maps into 83 to 97. Right. Which will also match. All right, this was 83 here. Huh. Okay. To recheck, because I'm not sure this is correct anymore, but it will be a lot easier to debug once we have it. So now we need to generate this particular map. How do we generate maps? I always forget. Is there something called scan? Num.scan applies the given function to each element in the enumerable, storing the result in a list and passing it as an accumulator to the next computation. Uses the first element in the enumerable as the starting value. Yes, this is kind of what we want. So .scan, and it takes an element and the accumulator, and then it returns something. So it returns a map. It takes a map, and we're just going to say the last map, and then it will return something. We're just going to return if last map dot src plus last map dot len is strictly less than map.src -1 do. Then we're also going to have an else case. So if it is, then we're going to return two maps. Right now, this is throwing the result in a list and passing it as the accumulator for the next computation. Ugh. This isn't quite what we want, actually. But I think it will work. Right. And this will start with list dot first. This will start with something. Okay, so if the last map didn't reach up to our current map, then we're going to create a new map, and it's going to start at lastmap.src plus lastmap.len, and its destination is going to be lastmap.src, so it's a map from itself to itself. We're not actually changing anything. And the len is going to be map.src minus lastmap.src. And we're also going to return map. And if none of this, and if the last map does actually extend to our current map, so we can actually flip this and make it easier to reason about. If the last map plus its length equals the start of the current map, then we just return the current map. Otherwise, we generate a new intermediary map. Okay. Here. Map list is this. I'm just going to give things names because doing everything in a pipeline is tricky. So we're going to do scan. We're scanning over the map list, but our accumulator is actually list.first of map list. Yes. And then here, this is actually going to be a list previous maps. And last, well, not previous map, this is going to be maps from last step. Then last map is going to be list.last of maps from last step. What's this going to do? This will give an error. Unexpected token. Right. So this is if fn, this fn ends here. I forgot the curly bracket, a square bracket here. Okay, so now this returns the new maps, and it returns only one element instead of multiple elements. What does scan actually return? Storing the last element in the list and passing it as an accumulator for the next computation. Right, so this should return all of the intermediate values, right? Applies the given function to each element, storing the result in a list. Storing the result in a list and passing it as the accumulator to the next computation, yes. Oh, I'm not actually doing the pipe here. Okay, now we get more maps. We shouldn't be getting 2 stages of maps. That's just wrong. Oh, this is not correct. Is it? Oh, no, this is fine. So, new maps. New maps should be happening. This is indeed new maps. Oh, and here we have to flatten after this, don't we? Why is this? It's returning two maps. It's a returning list of two maps because it always returns lists of two maps. Because that's what we're generating here. This is lists of two maps. So this is slightly confusing because and this map should be the same as this map. No. This should also never generate a map of length 0. If it's a map of length 0, then I screwed something up. The fact that the map ends is printed out in this format is really confusing. I'd really rather it say src len and 0. How does the inspect protocol work? The inspect protocol converts an Elixir data structure into an algebra document. But I don't want to define a type for this. Maybe I just should. All right, let's def module. What do we call this? We call it transform. Do def struct, and it will have src. Actually, let's just clean up our naming convention here. Start to and length. And this here says I can do derive inspect. This still compiles. The inspect protocol has already been consolidated. An implementation for transform has no effect. So I guess we can't derive protocols in a live book. That's frustrating. Right, I guess we soldier through this. So we start with the first map is going to be from 83 to 50 of length 0. This is just completely wrong. The first map should be this accumulator here. So here we return last map. And this didn't change anything because we're never actually in this case. But returning pairs of two things is going to be helpful for later. Next up here. So this we're going to call the new map list. The new map list. And we're actually going to return list.first.maplist and then prepend it to the new map list. So now we start with 50, length 33, and destination 52. This is indeed our first one. Next up, we want to start with 83 and go to 97. We start with 83. It got the destination wrong, and it said length 0. So the logic here must be completely wrong somehow. Let's do AoInspect. Comparing last map with map. Not comparing, checking between these two. Inspect this. Inspect this. Okay, so it does two stages. It checks between 50, this is the correct one, and then 50 length 33, this is not correct. It should be checking between this one, it should be checking between the first one and the second one. What's map? Oh, this should actually be tail, shouldn't it? Okay, checking between, we need to treat the first case specially, so we then need to map over everything except for the first case. So checking between 50 and then 98 length 2, okay? And then we have the first one. Then we start at 83, then have a length of 48. Like this length is completely wrong. And then, yeah, the last one gets confused. So why is this length completely wrong? It starts at 83. Is 83 the right starting point? Yes. So SRC is correct. Then dust is wrong. Dust should be the same as SRC because, as we've said before, this is a unit map. Last map.len. Okay. So this is, the destination is now correct. So now question is length. What should the length be? The length should be whatever we're missing between these two things. And what we're missing is SRC minus SRC minus length. SRC minus SRC minus last map.length. 15. Is 15 good? 83 plus 15 is 98. This is one too many. $83 of length 14. So 83 of length 14, and this is indeed length 14. Okay, now the shape of this result is pretty bad. I want to merge these. And if we have multiple maps here, then we'll get multiple of these pairs. So do I want to flatten? I don't want to flatten. I mean, I could flatten and dedupe. The problem is we're definitely going to get duplicates here because we return map here. Okay, well, let's make our example more complicated. I'm going to delete this because I don't want to think about it again. So, maps. What happens if we have another map here? This map is going to map to, I don't know, 1. It starts at 100, which is indeed the next one, and it's of length 50. And then our range here, instead of being 21, is going to be 50. Okay, so now we can see the duplication. This is duplicated with this. Yeah, so screw it. I'm just going to list flatten, list unique, and num unique. Right. So this is not the cleanest thing, but it should work. So we start at 50, then 83, then 98, then 100. And 50 plus 33 is the next start. 98, 83 plus 14. No, this is wrong. There's an off by 1 error here. So this one's correct. This one... Oh no, this one's also correct because this one goes to 97. And this one starts at 98 and goes for 2. which is up to 99. And then this one starts at 100 and goes for however long it goes. Okay, so now I have the much better maps. Yeah, let's... Do I have an IO spec in the middle of this? Of course I do. So this we can comment out, and now we just have the result. So we start with this, and then we enrich it to this. Specifically, we fill in the blanks. Let's put this whole thing in a function, because we're going to forget what it does otherwise. Def enrich map list. And it takes a map list, and it returns a map list. And we'll just do this, all of this. And here a bit below, we can call enrich map list here. AoC enrich map list with one argument. Syntax error. No equals here, of course. Function AoC enrich. Yes, this is AoC 3. Okay, and we're back to our thing. So now we have better maps. And we can inspect this here as well. So our next stage is we need to pass the seeds. We need to pass each seed through the map list at every stage of the transformation. But rather than every seed, we need to pass every seed range through the map list. And passing a seed range through a map list is possibly going to result in multiple seed ranges. So, seeds is seeds, maps is maps. Now we take each seed range. Let's actually call these seed ranges. Yeah, this is clear. Seed ranges. Seed ranges. Seed ranges. Dot map. Seed. Processing seed range. Let's just say like this. And we are processing that seed range, yes. Can I do IO put s here? I've been wondering. Yes, I can. Processing seed range. Okay, and now seed range, we have to actually pass through every stage in the maps. So maps, this is going to be a reduce of some sort. And we start with the seed range, and we take a map list and seed start and seed len. And we are processing seed start to seed start plus seed length -1. through, let's say, inspect map list. Just printing this out so that I can think of it clearer. The following arguments were given. No function clause matching. This really should be a tuple, but in fact it's a list because of the chunk by we did earlier. And so this chunk every actually generates lists, whether we'd really rather it generate tuples. Can we do list to enum or something? List to tuple. Tuple. Maybe a list to tuple? List to tuple. Oh, there is a list to tuple. Okay, so here this really should be a tuple. So we're going to make it a tuple. And after this every chunk every here, we're going to do enum.map list to tuple. And then we're going to split it onto multiple lines. Right, and now it's processing. Now it doesn't even do the char list display thing anymore, so it looks better. So it's processing 79 to 128 through. Through our 4 maps. Okay. Next up, what do we do? We have to find. Now we have to do our recursive function. We know it will be a recursive function because we tried to do this earlier and we ended up needing a recursive function. So we're going to say AoC 3 traverse range. Traverse range, yes. And we take seed start. Let's just call this seed range. So we take seed range and the map list. And this should hopefully return, and the idea is that this will return multiple ranges. It will return like these 3 things instead of just one thing. Yeah. Traverse range. And then we take a seed start, seed end, and the map list. Right. And now we know that so we have 2 advantages over last time. We know that map list is complete, so there are no holes in it, and we know that it's sorted. So what is this? This is a sort of a reduce, I guess. We want to iterate through every element in the map list. And if seed start is in the range for that map, then we do the map and then we reduce we increase seed start to something and then decrease seed length by something. And then we keep on going. Right, so this is map list enum.reduce. We actually start with this. So this is called seed range. We start with seed range, And then at each step we take a map, we break apart the seed range, and we do something. And not just the seed range, we're going to do... Yeah, this is going to have to be a list. And we're going to keep prepending it. We'll do it the wrong way around, because that's easier to match upon here. No, we shouldn't do that. That's just going to result in a bug later on. So this is going to be our input, and this is going to be our output. And here, same thing. We have a seed range, and we have a result. And we have a result. So if seed start is greater or equal to map.src, then we are in the current map and we have to do something. Otherwise, we are not in the current map and otherwise we just keep on going, and a later map will have to handle this. So otherwise we just seedlen and res. Otherwise we don't do anything and we just keep on going. However, if the seed start is greater than map src, we know that this must be the first map to match. So new seed start. No, now we have two cases. The first case is whether our entire seed range is in this map, and our second case is if it's not in this map. So if seed start plus seed length is greater or equal to map.src plus map.length, then we are not completely included. Otherwise, we are completely included. Included, and here. If we are completely included, then we're just going to return seed start. So the length, going forward, the length is going to be 0. And this doesn't matter anymore, so this is also going to be 0. What matters, however, is the result. And the result is going to have something, a const onto the front of it. And that something is going to be the seed going through the transformation. So instead of seed start, we're going to do... Well, we're going to do traverse, right? We're just going to call the traverse function from the first... Yes, we're going to do the traverse function from the first part. So where are we? We are here. So here we're going to do... What was the logic? I'm just going to write the logic again so that I don't have to check it before. It's num plus the dest minus source. Here. So it's num plus map dot dest minus map dot source. Really? It's not a plus, there's no +1 in there? I guess there isn't. And then the length of this is going to be, well, it's still going to be seedlen. Which we know is and we know that seed len is smaller than the map length because of this comparison here. And this should work, although it's really ugly that we're using the 0 here to sort of trick it. No match. The following arguments were given to anonymous function fn. Not. Wait, I still have a not included? Oh, I forgot to calculate this one. Oh, so this is the case where we're fully included, and this is the case where we're not fully included. So we're still going to have to const something onto the result, and the thing we're going to const is seed start plus map.test minus map.src. The transformation still happens the same, just we're going to have less of a seed length. Let's just compute it ahead of time here. The new seed length, this is let's do map length. Map length is going to be map.src plus map.len. So this is how far we can go through the mapping, minus seed start it's how, okay, this is better written as map.len. So how long we have the map minus seed start minus map.src. Right, okay, so if map.len, now we can do this, we can simplify this a bit. If map.len is less than or equal to map.len, then we can completely include it. Otherwise, we have to handle just a part of it. So then we're going to do seed.len minus map.len. No, this is not right. If the map length is less than the seed length, then we do this. Otherwise, and it has to be like this for the logic to work. Okay. And then what do we have? We have, this is going to be the next accumulator, so the restricted seed range that we're processing. The restricted seed range is going to be seed start plus map.len, and the length is going to be seed.len minus map length, how much of it is left. Okay, so this is actually wrong here. This shouldn't be seed.len minus map length, this should be something else. This should be map length, because this is how much we've mapped. Okay, this should run, but it won't do anything useful. Yeah, it always ends in 0, 0. That's not good. We're just going to drop the first element of the accumulator here. Oh, so this is just really hard to think about. So we're just going to do the recursive function as we wanted to at the beginning. So we take a seed range and the map list. Let's just copy the, shall we copy this? No. This is really tricky code to write. Seed range, seed start, seed.len. And then here map list, we're actually going to do map concatenated with const with map list. And I don't know what the base case here is going to be. So we stop doing the reduce, which is just really hard to think about. We can de-indent this a bit. All right. So going back to the logic, if c.start is greater than map src, then we do something. Otherwise, we now recurse. We do traverse range of map list. Right? We traverse. We just keep on going. We just keep on searching through the map list for a map that does actually contain at least part of the seed. If it does contain part of the seed, then we compute how much. Let's just compute all of the values here, right? So mapped start is going to be seed start plus map.test minus map.src. This is where the mapped seed will start. Map length is going to be how much of it we can map. So how much of it we can map is the maximum map length, map.length, minus c.src minus map.src. And there might be an off by one error here. So let's reason through it. We want to map, let's say as an example, this. So this is our map, and then we're going to say our seed is, let's do a simpler map. Let's say our map is 50 to 60, and this maps to 70 to 80. And then our seed is going to be 55 to 60 for now. And this should correctly maps to, we add 20, so this will be 75 to 90. Okay, so map start, put this here. So map start works, right? Because map test minus map src, this is 20, and then this is 20. The difference is 20, so it will work. Mapped length. Mapped length will be what? Well, in this case, it should be all of it. And in some cases, it will not be all of it. Right? Because mapped length is always the same as seed length, except if we have to cut it. So we have to do a check to see if we cut or not. What's the check to see if we cut or not? The check is seed start minus map.src. So this is how far we are currently into the map. And so here it will be 5. 5. And then we have map.length minus this. This is how much we can actually map without cutting. And so map length is 10, and then it will be 10 minus 5, 5. And if this is smaller than or equal to c.length, then we don't need to cut. Otherwise, we need to cut. So no cuts. Cut. Okay, so in the no-cut case, it's pretty easy. So in the no-cut case, we have a no-cut case and the cut case. The no-cut case ends the recursion. So we just have to return a list with seed start. Right? No, we have to return a list with map start and seed length. And we know that this works because the mapped version, the mapped thing is less than our seed length. No, the other way around. Yeah, the seed length is less than the amount that we can still get out of this map. So here we just return this. But in this case we have to cut. In the other case we have to cut. So the question is, how much is our new seed going to be? And I think it has to be this, right? Which is going to be strictly less than seed length. Now we can save this. So mapped length is this. Now this is max mapped length. Yeah, this is what this is. Okay. So we're cutting here. So here we're going to return our current seed, and then we're going to return our current map, this mapping of the current seed, and then we're going to continue traversing. So our current thing is map.start and max mapped length. And it has to be like this. Yes. And then traverse range, the next seed is going to be seed start plus max map length, because this is what's left over, and the length is going to be seed length minus max map length. And let's just fully indent this so that we can see what's going on. Now if I run this, it will throw an error. Why? Because we don't have a base case. So we ended up in 97. So we ran out of things to map through. Let's add some IO inspects. Let's print out what we're actually doing here. IO.putS mapping, what do you call it? Seed start. Seed start plus seed len minus 1 through inspect map. Okay, so here we go. We start with 79 through 128 and we try to get it through this particular map. I'm just going to add a pretty printer for the map because this is unreadable. Let's just say the pretty src dust len. This is going to return src ... src plus len minus 1 Unicode character for arrow to best dot dot best plus len minus 1. And then here we're not going to do pretty map, inspect map, we're going to do pretty map instead. Right. Okay, so we're mapping this range through this particular map. So it should do something. Let's also output what we're generating. Spec. Oh, actually in this is going to be called a partial, and we're going to do map start dot map start plus max map len minus 1, and then we're going to do the same in the above case, and here we're going to say complete, and this is map start plus map start to seed len. Why is it showing me some did inspect instead of put as? Okay, so mapping 79 to 128 through this map. And the result of this is 81 to 84. Well, this doesn't look right. Surely it can do more than 84. Yeah, this should pick up at least like 32 numbers. Yes. So the partial computation is wrong. Well, IO inspect max map len. What's a max map len? 4. 4 is definitely not correct. The correct number here should be max map length. Yeah, the correct number should be 82 minus 52, so... Oh no, this is correct, isn't it? Because 82 minus 79. So we can do 79, 80, 81, and 82. So this is 4. This is actually right. Okay. So we mapped this, and then next up we're going to map 83. Let's also... Oh, right, 83. 83 through 128. This is because it already mapped 4 things. So the next one is going to be 83. And then it tries to map this through 83 through 96. Okay, so we can do the full 83 through 96 mapping here. Next up is 97 through 128. 97 through 128. Oh, is there a hole here? There's a hole in our data. Right? There's... So 83 plus 14 is 97. There's a hole here. So that's what's wrong. So this is not quite right. The length isn't right somehow. Are the other lengths right? So it's 50 plus 33 is 83. Good. 83 plus 14 is 97. Bad. 98 plus 2 is 100. Good. Oh, so just one of them is wrong. This is 98 was one of the original numbers, wasn't it? Yes. So it's failing to stitch them together somehow. Well, if this was... so this is a flank 2. It's 98 and 99. Right, so this is right. This is actually also right. It's 83 through 14, 97. No, this is not. This is 1 too little. It should be plus 1. So here it's perhaps like this. What's going to happen now? Okay, so we have 50, 33, 83, 15 to 98. All right, this works. Back to here. I should really check the destination. Let's assume it's correct for now, and we'll debug it later if it isn't correct. Here, we do the partial match here. Then we have 98 through 128. We have to map through 898, 99, and so on. So this maps to 50, 51. Yep. And then 100 through 128, all of the remaining ones. And this just goes to 1 through 29. And the output is 81 of length 4, 83 of length 15. Is this 15? Yes, it is 15. Then 50 of length 2, and 1 through 29. 1 of length 29. Okay, so traverse range does what I think it should do. But this returns a list. And going back to here, we're actually expecting a single seed. So really, this is sort of an explosive thing where at every stage, we're going to flat map. Right. So we start with a list of a single seed range. Then here, we don't have one seed range, we have many seed ranges. So then we take the seed ranges and then we flat map them. So this is basically the same as before, except we're now expecting to receive a list of many things and then returning, we're expecting to return a list of things. All right. There's one too many. Why is this? Where is this extra list coming from? I think it must be coming from here, right? So I'm just going to map this into something to give it a name. Seed ranges? Yes, okay, so each seed goes into a bunch of seed, leads to a bunch of seed ranges at the end, which is expected. So now, instead of doing just one map, let's do 2 maps. Okay, and it errored out again, but we can debug this. So it was processing 81 through 84. Oh, I should also... Yeah, I should also delete these comments here since they're going to be confusing at some point. I wonder if these overlap, because I wrote my example completely carelessly. So let's just copy their example again. Yes, and then clear the clipboard to get rid of the live view bug. Reload. Okay, and now I run this. And it's still errored out, but it's easier to reason about now. So we have 8, or rather, we know that it shouldn't error out now. 81 through 94, and then it tries to pass this through 0, 14, then 15 through 51, 52 to 53. Fine. Oh, when we're filling out the holes like we did, we failed to fill out the hole at the very end. Right, so if you end up here, if you end up in this case here, there might be a huge hole at the end. So how do we do this? Okay, so the problem is here, we're not filling out the hole at the end, and also not filling out the hole at the beginning. Right, so holes filled is this. And then instead of just returning holes filled, we have to also return some, fill out the hole at the beginning, and then fill out the hole at the end. The hole at the beginning is easy because it starts at 1 and ends at whatever the first number is. Oh, 0, 14. You can start at 0. Really? Okay, so first hole starts at 0. All right. So let's do this. If list.first.holesfilled.src is not 0, then we are going to do map src is 0, destination is 0, and length is first. Is first.src. Prepended to holes filled. And then we're always going to have a last one, which is going to be list.last holes filled. And then we're going to generate to infinity, which is going to be a map that starts at src is last.src plus last.length. The destination is last.src because this is another unit map. And then the length is going to be $10 billion. Is 10 billion big enough? What do these numbers look like? So these are hundreds of millions. This is 1 billion. Let's do 100 billion. And let's also collapse part 1 since we're never looking at it again. Okay, And then here we also add to infinity at the end. And if the source was in fact 0, then we just do holes filled plus to infinity. Yep, and this kind of worked, except this does not look right. Probably shouldn't go into a negative number. Okay, so we mapped 52 to 94. To 94 to 014. Why did it get a match? 91 to 53. Yeah, this partial match here is completely wrong. Why? Oh yeah, this is actually pretty wrong too, isn't it? It's mapping this through 0 to 49, so it shouldn't find a match. If c.start is greater than map.src, if c.start is greater than map.src, then we print something else here. Otherwise, let's just write here io put s no match. If c.start is greater than... we have to check the ending. We have to check the ending, of course. If c.start is greater than map.src and c.start is less than or equal to is strictly less than map.src plus map.length. Okay, now this is looking better. So mapping 79 through 049, no match. Mapping 79 through 92, same thing as before through the new first thing. This does match 81 through 94. This is... I want to write complete here. Let's also write what we want to write. But this is showing just the result. Actually, partial is the more annoying one, right? Well, okay, so incomplete, it will just say seed start dot dot seed dot start plus seed dot length minus 1. Right. So now you can see what the actual match was. It matched the entirety of it, and it matched it over to 81 through 94. Which is at least in the range there. Okay, so here, matching 81 through that, it's not. 81 through 51, no. 81 through 94 through this thing to up to 53, nope. And then matching it through the very end, we get 81 through 94 leads to... This feels like this should have been a unit. No? Yeah, this should have been a unit. Why did to infinity... here. Plus last plus len. Complete. Okay. Alright, let's add more stages. What's stage 3? Processing 81 through 94. It again just doesn't change. Okay, let's just send them through all the... Right, here we go. 8194. Then 8194. Now, here we found a full match. 8194 goes through 25, is included in 25 to 94. So it goes to this. Right, like 25, this is minus 7. 25 to 18 is minus 7. So 81 is minus 7 is 74. And then 94 minus 7 is 87. Okay? And here we have our first partial match. 74 through 87 goes through this, and it results in one partial and then in a second partial. Let's improve our printing of partials here. Feed start plus max map learn minus 1. So where is the partial? Here's the partial. 8194, and then here we go. 74 through 87, it matches 3 things. So it's 74 to 76, which is correct, and this turns into 78, because this just adds 4 to 80. All right, this is correct. And then the next one is 77, which is the one after this, to 87. And this becomes 77. 77 to 87 becomes 45 to 45. Because this here is doing... What's this doing? This is doing 77 minus 45. So this is 32. And then 45. Okay. And 87 minus 45 is going to be obviously 55. And then presumably it does the processing correctly, and we end up with these 3 seed ranges. Okay, let's remove the second take we had here, where we only looked at some of the seed ranges. Where is it? Here. So now we have 2 sets of seed ranges. And what's our actual question? What is the lowest location that corresponds to any of the initial seed numbers? And they're saying that the lowest location is 46. So indeed, we have 46. Do we have anything lower than 46? We do not. Okay, let's not call these seed ranges anymore. Let's now do a flat map here to just combine all of the results. Yep. And now we only need the smallest number. So really, we just have to take the first element of this, because clearly we don't care about the length anymore. We only care about the initial start of the range. So here we're going to do lm.map fn range start, range len. We only return range start. lm.map is undefined, and num.map. Okay, and now we just do a num.min. 46. Okay. And now what happens if we run this on full? We end up with this, whatever it is. Wow, that's the right answer. Yes! This was actually hard. This was actually hard. Ah. Day 5. Day 5. Hit the bloody Livebook bug again, but now we clear clipboard and let's think about this for a second. We don't care about part 1 because part 1 is trivial. We care about part 2. We don't need the test input anymore. Well, yesterday I was complaining that it seemed too easy. Today it wasn't easy. But could we have done this in an easier way? Because this seemed like a lot of work. So we're doing one step that maybe we can avoid is filling in the holes here. But that feels like it's just going to make this pretty hairy logic even hairier. We already have like 2 nested ifs here where we have, where we check if, okay, so the first if is probably pretty easy to handle though. Like the first if, it just checks if the current, okay, so if we didn't have all of the holes filled, then here, when the current range isn't actually included in the map, then we'd have to do something much more complicated here. Rather, not much more complicated exactly, we just need another one of these things where we do some tricky computations that may or may not have an off by 1 error in them. We're also doing the sort of hacky thing where we add the fake maps at the beginning and at the end. And again, if they were missing, then this would just result with much hairier logic here. We could handle the numbers, like the 0 and 100 million are magic numbers. We could perhaps handle those differently by having a special infinity range. But if we do that, again, hairier logic. A lot of the hairiness of this logic really is that we're not dealing with ranges properly. Or rather, every single time we're treating ranges as separate things where we have a start and a length. But the way I think about these at least looks like this. Like this is what a map is. It's a pair of 2 ranges. The ranges happen to be the same length, but they don't need to be. So maybe we could simplify things if we had better data structures. If we had better data structures, so for instance, if we had a range data structure, we could get rid of some of these pairs. But then, like, the important bit is, would it simplify this logic here? Because this is the hard bit. Instead of doing this maxed map length computation thing, we could do intersections of ranges. But then we'd still need to generate the new ranges below, so it wouldn't help much, I think. Yes. I think if we had special data structures for ranges and maps, it would make the code a bit more readable, but it would still be equally error prone. So I think we're just going to leave it at this. Yes, maybe if tomorrow's if tomorrow's problem is very easy, then we'll have time to refactor this. What do the stats look like for today? Yep, only a quarter of the number of people from yesterday have solved the second part so far. Interestingly enough, almost everybody who solved the first part has also solved the second part, which either shows dedication or shows that I missed something. Oh, can we hack this? Can we hack this? Because I've been doing the principled thing and actually computing the whole ranges that go through. But really, we don't need the whole ranges, do we? Because we know at the very end, we just take the start of the range. We just select only the start of the ranges and then compute the minimum. So we just need the range starts. We don't need the range lengths anywhere. But we need the range lengths in order to do the traversal, so no, we can't hack this. At least not in any way that I can see. Alright, then I think that's going to be it for today. We solved day 5. What were we even doing here? We solved day 5 and averted the famine on Island. But the result is hacky as hell. Or it's complicated as hell and error prone. I really would not like... I would be very unhappy if I ever found this code in any code base that I have to maintain. But it's good enough for this particular competition problem. So, that's it. Thank you for listening and see you all tomorrow.